Okay, boys and girls, so today we're going to continue our study, our geology study of volcanoes, geysers, and hot springs. Okay, so we're on lesson 6 on our unit 8. Okay. And our objectives today, what we're focusing on learning, is making inferences and using our text to support any inferences we make sure that we support them with evidence. We have also been practicing supporting our responses with our text evidence. We are really focusing on using the new vocabulary, not just learning it, but using it today. And again, we're still working with learning words that have the suffix ly and using commas. So that'll be at the end of our lesson today. But for now, again, we're going to be focusing on using text evidence in a couple of different ways. To begin with, how do we feel right now about using text evidence now that we have been practicing writing our short constructed responses and our extended constructed responses? Are we comfortable yet? I know at the beginning of the year we were in the 1 and 2 areas of our learning. But are we now feeling like masters, experts, or are we still unsure? Show me with your signals. Okay. Yeah, a lot of you are at the 3 and 4 level, which is great. But again, practice makes perfect. So the more we practice, the more comfortable you're going to feel with it. Great. So let's see if we can move some of those 3s to 4s. So today we're starting with our reader. If you will use your table of contents, remember that's one of our favorite text features. We don't have to go page by page. We can use our table of contents to help us find which chapter we're on. Today we're on chapter 4. Andrea, what page is that? Chapter 4? Yes, chapter 4. According to the table of contents, where is that?
According to the table of contents, chapter 4
right here.
Is
on what page?
On page 32.
Good job. Okay, so everyone turn to page 32. Give me a thumbs up when you're there. Okay, everyone is there. What is the title of today's, Eliana, what is the title of today's chapter?
Fiery volcanoes.
Yes. So our focus today as we read, what we're trying to take from the text is how do scientists determine where volcanoes might develop? Okay. We've been studying everything from plate tectonics to faults, and scientists use those things to determine where these natural phenomena happen, okay? So that's what we are going to be focusing on, is how do they determine where volcanoes might form? So we are going to be reading chapter 4, and we're going to start on page 32. We do have 2 different vocabulary words that we'll be covering today. What is the first one, Vinny? And what is a volcano? What do we know about volcanoes already? I want you to access your schema. What do you already know about volcanoes? Sophia?
Burst out lava.
Okay, so she says they tend to burst out lava. Okay, Lismar?
Volcanoes are formed by like a slight shift in the earth when it pops up.
Oh, we studied that. What was that movement from plate tectonics? Do you remember, Reina? Where the pressure builds when they collide together. I know Eliana's got these memorized. Eliana, help out Reina.
Is it transform?
Okay, transform. Do it with your hands. What was transform? Oh, I see Lismar already. Transform is when they slide next to each other. Subduction, show me with your hands. Yep, where they go, one goes under. Remember the prefix sub means below, so it slips under. This one is actually, is it a divergent or a convergent? Convergent, yes, a convergent collide of plate tectonics. So very good, Lismar. We're going to see if Lismar is correct. So we're going to read from page 32. Before we start, really quickly, Ezekiel, what is a crater? We're going to hear the word crater today. What does it mean?
It means like a hole shape, like hole in something.
A bowl shape. Your hands. A crater might look something like this, right? It makes this hole in the volcano where the lava usually spills out of. So on page 32, who would like to read? Okay. Abby?
Imagine seeing new lands form right before your eyes. You can do just that on the island of Hawaii and
Oh, okay, so we have a word here that we may not know how to pronounce. We have the pronunciation table down here. It's pronounced Kailua. Kailua. Mm-hmm. So go ahead.
island chain. There, the Kailua volcano has been erupting constantly since 1983. At times, red hot lava shoots out the crater at the volcano's top. More often, lava oozes out of the cracks on the volcano sides. As the lava flows downhill, it cools and hardens into volcanic rock. When lava flows all the way to the ocean, it cools to form rock along the shore. This adds new land to the island, making it a little bigger than it was before.
Okay, so remember, as good readers, we always imagine what that might look like. Okay, so the way this is described looks like when lava flows all the way through a volcano, when it comes out, it pours down the sides, and then what does it describe? How does the author describe this? What does he say, Eliana?
He describes the crater, like the inside of it, like the bowl shape,
Mm-hmm.
and how it's like erupting and everything, and how it's like dripping down.
Right, so it drips down the side of the volcano. What happens when it cools?
It turns into igneous rock.
Oh, it turns into igneous rocks. Yes, it does. We know that igneous rocks are a result of magma, or they come from volcanoes. So go ahead, Adi.
Erupting volcanoes are traumatic natural events. They can be a creative force, adding new land, even whole islands to our planet. They also bring minerals from deep inside the earth to the surface. However, volcanoes can be dangerous and destructive. Large volcanic eruptions can flatten entire forests.
Yes, they can flatten entire forests. Those are very, very powerful. Keep going, hon.
They can fill the air with poisonous gases and hot choking ash. They can release rivers of lava that burn and bury everything in their path. Erupting volcanoes can also trigger earthquakes, tsunamis, and landslides. They can even change the weather all around the world.
Okay, so in this section, we had some key ideas there. What was one of the things that was talked about most in that paragraph, in the second paragraph? Erasmo?
A volcano called a volcano erupting.
Okay, so a volcano erupting, and you want to extend on that, James?
The dangerous effects of volcanoes erupting.
Basically the effects. So I want you really quickly to highlight some evidence, because I'm going to have you talk to your neighbor in just a second. What are some, you're going to answer this question. What are some ways in which erupting volcanoes can change the Earth's surface? So there are, remember that if you don't have a highlighter, you've got one here. Okay, so highlight some evidence, because you are going to turn and talk to your neighbor here in just a second. You're going to talk to them about different ways that volcanoes erupting changes the Earth's surface. Okay, I see that Lizmar's already got some ideas. I'm going to give you about another 8 seconds. Okay. Okay, so with your learning partner, you are going to turn and talk. You are going to talk to them about some ways in which erupting volcanoes change the Earth's surface. Okay? Are we ready? Okay. Teach.
Okay.
Go for it.
Volcanoes.
You can go ahead, Lizmar. You can go to her. Okay. Teach.
Okay.
Go for it. Okay, that's a new one to me. I didn't know that. But I guess if you're close
As the lava
enough.
flows down the hill, it cools and condensates into volcanic rock. When lava flows all the way down to the ocean, it cools to form rock
Again, those are all different. I didn't know those.
along the shore. This adds more land to
They're
the
so powerful.
island.
They take out the entire forest. Okay.
I think I have a
Geologists ready?
ready to rock.
Okay, boys and girls, and we're going to do a cold call. Now that you've shared with your neighbor, I want somebody to share at least one way that volcanoes change the Earth's surface. Erasmo. One way that volcanoes change the Earth's surface.
One way that volcanoes have changed this Earth's surface is
Take your time on it. It's okay. Look, just check your text evidence. You were sharing lots just a second ago.
As the lava flows down the hill, it cools and hardens into volcanic rock. When lava flows all the way down to the ocean, it cools to form a rock along the shore.
Okay, so that means that one way that the lava turns, can somebody clarify that for us? Okay, Lizmar?
So I was saying that, like, one way the volcanoes can change Earth's surface is like when the volcano erupts. It makes lava dripping down the volcano, and then it eventually cools, adding new land to the Earth's surface.
Beautiful. Very well stated. Great job. Using your hand signals, does anybody have anything they'd like to add on? Okay, Eliana?
They can, volcanoes can release poisonous gas and hot choking ash.
Yes, they can. So, well, does that cause changes to the surface, or it does cause changes to the atmosphere? So, yes, hot choking ash. Okay, so we've got a lot that want to add on. We can take one more. Bryson, what do you want to add there?
I found in the text that it says they can release rivers of lava that burn and bury everything in their path.
So imagine that. There are sometimes towns and cities, forests, things like that, around these volcanoes. If that lava drips all the way down there, what is it saying according to the text? What exactly could happen?
It can burn people's houses.
Everything.
And even people.
Even people, if there are people stuck inside. And that actually, unfortunately, has happened in history. So great job, boys and girls. Let's give you guys a cowboy cheer. That was a wonderful discussion. 1, 2, 3. Yeah. Good job. Okay, so as we continue on, this is something I've been dying to share with you. The Kailua volcano is actually the most active volcano. So there is a live camera on the volcano. So we're going to get to see that. So that, and if we use this text feature, we have a map up here. What do maps help us with?
Finding places,
You can share
islands,
it. Finding the location of places, right? Okay, so this one is actually located on the big island of Hawaii. You see how Hawaii is a string of islands, but one is the big island, and that's where this is located. I tried to link the video, and it didn't quite work, so we're going to... This is a live feed of this volcano, boys and girls. Light helper, can we get the lights, please? Okay, so earlier this morning when my first class saw this, it was dark. It was pitch black. So what can we infer if it was pitch black when we were already in daylight? James?
It had been erupting and the smoke was coming out.
Okay, that might, I see where you're going with that. Okay. Ezekiel?
Like the ashes from the eruption, like, got onto the ground.
Possibly, that's another possibility. But let's think of some of the things you've learned in science. The globe, the earth rotates. Okay, Vinny?
It was dark over there because over there is like kind of like the other side of the world, and
Right, they're very far from us.
it was dark over there.
Yes, so here it was daylight, they were still at nighttime. So right now, this is what the volcano is doing. So we're going to keep monitoring this volcano throughout our study. We'll keep checking on it while you're working. I'm going to have this as our screensaver so you can see what it's doing. I'm really hoping we get to see it erupt. It is pretty active, so hopefully we'll get to see it erupt. But in case you want to watch this at home, if you want to keep up with it at home, just on YouTube, all you're Googling is active volcano, live volcano camera, and it's the first thing that pops up. So the Kailua Island, the Kailua volcano does have a live feed camera on it all the time. So what are some things we notice?
That it's smoking.
It's smoking. So, anything, Erasmo?
There's some evaporation going up the hill.
Oh, I see. Okay, where it's trailing up. One of the questions that one of the students in the other class asked is, why is there two? Why is there two craters? He used the correct vocabulary word. He said, why are there two? Well, it's a huge volcano, so it can have more than one crater where lava spills out. Okay. Oh, there is, right? So this is really cool. We'll be monitoring this volcano throughout this unit of study, so you can always come back to it. And we'll leave this open as we're working so we can kind of look up and hopefully catch some activity in there. So that. Okay, the next word that we're going to run into is the word fine. Now, the way it's described is it is an adjective, and it means something that is very small. So if you've ever seen a fire burn out, maybe in your fireplace, maybe in, like if your parents are barbecuing, the ash is what's left over. What color is ash normally? Cheryl?
Brown.
Like brown, gray. What could you compare it to? It's as fine as, I kind of always picture it as like powder. Like baby powder, it kind of resembles baby powder.
The dust that we have in Texas a bunch.
That's possible. Where did I leave my... Okay, so we're going to read a little bit about the year without summer. Go for it, Lismar.
In the spring of
1815. Mm-hmm.
A volcano called Tamba erupted in this really hot way.
You're going to break it up. Break it up, hon. In Indonesia. Good job.
It was the largest volcanic eruption in recorded history. Tamba's eruption blasted enormous amounts of ash high into the atmosphere. In the months that followed, winds
Distributed.
Give her a chance.
distributed the ash around the globe. The fine ash particles in the air block some of the sunlight reaching Earth's surface. Less sunlight meant less warmth. Because of Tambar, the weather was much colder than normal in 1816.
Okay, keep going.
There were hard frosts in New England all summer long. A foot of snow fell in the eastern Canada in June. Weeks of cold rain killed most of the crop in Europe. Many people call 1816 the year without a summer.
From what you've studied in science, what do you know that the sun provides for us? You can share out. Okay, warmth, heat. So if the volcanic blast was so big that it caused these huge clouds of ash to block the sun, what are we going to lack on Earth? I'm sorry?
No light either.
There was probably not as much light. We know the way it looks on cloudy days. So,
There's probably like no board.
Miss probably
Probably
probably all the crops died off because it was cold, and even trees probably died off because there wasn't no sunlight to give them nutrients.
exactly. So, this, I couldn't understand how a volcano could affect weather around the world, but this actually explained it. The text actually explained it very well. So it explained that because it can block sunlight, it can affect weather all over the world, not just where the volcano is. Hold that thought, honey, and we're going to keep going. So on page 34, we are reading about what exactly is a volcano. So if we're at the top of page 34, I see that Vinny wants to read. Okay, Vinny, you're reading that paragraph for us. Go ahead.
What is a volcano? A volcano is a hill or mountain that forms over a crack in the Earth's crust, from which lava erupts. The crack leads down to a chamber or huge space filled with magma, which comes from the magmatic tremendous pressure and heat in the
Mantle. Remember where?
force magma in the chamber upward through the crack. If pressure is great enough, magma erupts on the surface as lava.
Okay, so there's a difference between magma and lava. Okay, where does that magma come from, Vinny? Earlier this week we made 3D diagrams of the layers of the earth. Which layer does it come from? The mantle. So the mantle is that area, the second layer of the earth. And what do we know, what can we recall about the mantle? What kind of, is it solid, liquid? Asen?
Solid.
The mantle?
The mantle, liquid. It's more like
It is made of rock.
mush, iron. It's like iron with still lava and stuff mixed. Copper, like all the kind of oils.
Right. Lots of different irons and minerals. It was a combination of both. And remember that the outside part of it was more solid, but the inside was more, it had some moving parts to it. So that's where the magma comes from.
The middle was combined with liquid and solid.
Right.
Mr. Mantle is like a liquidish, but it's also like,
It has a little bit of solid chunks.
So it kind of makes it like a mush.
It does. It does. So we're on page 35. James, will you go ahead?
Some volcanic eruptions are relatively calm and quiet, whereas others are sudden and violent. Each time lava erupts, a new layer of rock forms, making the volcano bigger and bigger. Forms making the volcano bigger and bigger. Many volcanoes gradually become high, cone-shaped mountains.
This is a tricky one. Vesuvius,
In
Italy.
Italy and Mount
Fiji.
Fiji in Japan are good examples of volcanoes with distinctive shape.
With this distinctive shape. I want you to read to the end of this page. Give me a thumbs up when you're done. Okay, so we have some new words in there. We have these three words. A volcano can be one of three. It can be either active, dormant, or extinct. Based on the text, Bryson, what does active mean?
Like it's ongoing.
Like it's ongoing. It erupts frequently and has erupted in how long? In the last...
10,000.
Yeah, I don't know why they use 10,000 as their measurement, but if it has erupted in the last 10,000 years, it's considered active. Now, what would be the characteristics of a dormant volcano? Bella?
When an active volcano hasn't erupted in a long time, it is considered a dormant volcano.
So if it hasn't erupted in a long time, then it is considered dormant. Now, Abby, share with us, what is an extinct volcano?
An extinct volcano is like, it hasn't erupted for at least like 10,000 years.
Okay, so lots, in a very, very, very long time. So that's the difference between the three. We also have a diagram. The text gives us a beautiful diagram of the inside of a volcano. I want you to notice the magma chamber and how it goes all the way up to the crater, and once it spills out, then that magma becomes, what does it become? Lava. That's the difference between magma and lava. Magma is inside the volcano, lava is outside once it comes out. Okay? So believe it or not, boys and girls, there are actually volcanoes in Texas. No, I know, that's what I said. So in Texas, over here in West Texas, there is the Trans-Pecos volcanic field, and it's located in West Texas and has not erupted in over an estimated 30 million years. It is a what? It is extinct, okay? So it is an extinct volcano. Now, from social studies, what do we know about this area? What region of Texas does this fall in? Can anybody tell me? TJ.
The mountain basin.
The Mountain Basin region, do we agree? Yes, this is the Mountain and Basin region, and some pictures from this area also help us recognize that. I'm sorry? It does have a lot of mountains. So that is located there.
My grandma lived in West Texas exactly at the
Does she really? So maybe you've been in that area and you don't know. Okay, so how?
You could tell that now there's plants and stuff growing on it, so they haven't been burned.
So obviously that hasn't happened. It hasn't erupted in a very long time. Okay. No? Okay, so some of the things I want us to learn about, what we're going to be discussing next is how exactly volcanoes can be both helpful and harmful. We had some information on these last 2 pages. So I'm going to give you a minute to find some text evidence as to how volcanoes can be both helpful and harmful. Find those because you are going to talk to your neighbor about those.
Oh, I know.
Okay, we got it. Give me a thumbs up when you've got some evidence that tells how they are helpful and how they can also be harmful. Okay. Ready? You're going to talk to your learning partner. Okay, ready? Teach.
Okay.
Go for it. Okay.
Okay. Volcanoes can be both helpful and harmful because first starting off with it can be helpful because as the lava flows downhill, it cools and hardens into volcanic rock, and then when it flows all the way down to the ocean, it cools to foam. It cools to form rock along the shore, and then the result is it adds new land to the island, making it a little bit bigger than it was before. And then it could be bad because the fine ash particles in the air can block some of the sunlight reaching Earth's surface. So, and less sunlight means less warmth.
Great job. Great job on that one. So according to the text,
I found some harmful.
okay, where was that? Well, it said, remember when you were the one that told me that it can level full forests, right?
So you can look at back at that page.
Helpful. I find helpful.
This I only found like Highland stuff.
Okay. But there were some, well, because remember they also, what do they do to islands?
Oh, they create new
Right. Okay, so find that evidence. New islands. So when they erupt,
Everything in their path.
okay.
Volcanoes can trigger. I already have my path. I got 2 ways. One way a volcano can be helpful when it erupts, it can make the island a little bit more bigger.
Good job. Beautiful text evidence. So talk to your neighbor. Make sure they know that in case they get called. Yes.
Can I do mine?
Erupting volcanoes are triggered. Ooh, okay. Is this helpful or harmful?
Harmful.
Yes. Very good. Okay. So are we having...
Ash. And the lava that burn and bury everything in their
New
path.
land to the island, making it a little bigger than
Okay. So what did y'all come up with?
I came up with the reason they're helpful is because it could form islands, so they give us more room to build stuff. They also bring minerals from deep inside.
Please highlight that one because I don't think anybody's recognized that one. Great job. Great job on that one. Okay, girls, you found it? Okay, good. Okay, so we're ready to share. Okay, so I'm going to let you lead this discussion. So using your hand signals, I want someone to tell me at least one reason why volcanoes can either be helpful or harmful. Signal when you have an answer. Okay. Vinny.
In my opinion, I think volcanoes can be helpful because every time they erupt, they shift. The erosion takes it to the water, and it adds to islands, and it sometimes creates islands.
Okay.
So they can be harmful.
Whoa, hold on. Let's stop with that though. Let's see how everybody feels about that. Okay, so we have lots of people who want to add on. Okay, so Vinny gave an example of how they are helpful. Liz Mark, go ahead.
Volcanoes can also be
is like, I don't know what I was gonna say.
Somebody like to help her? Hold on. Okay, so James wants to add on.
I want to add on some reasons they're destructive. Some reasons they're destructive is they could fill the air with poisonous gases, and they also could flatten forests and bury it.
Okay. So does someone have something they would like to add, like another reason how they are destructive, or do you have something different in mind? Okay, Sal?
I was thinking, I want to connect of what James said by saying that when it creates poison air, it won't have people won't have anything fresh to breathe in.
So that could
And when they breathe it in, there's a chance that they might die.
probably very true. Houston looks like
I want to add on to James' opinion because when it erupts, it can cause casualties and could be harmful to the environment and wildlife.
Go ahead, Delilah.
I would also like to add on to James is erupting volcanoes can also trigger earthquakes, tsunamis, and landslides.
Right, and we learned about those last week, so even we know those can be pretty harmful. Okay, you have some supporting evidence? Okay.
I want to support to what Sil said about if it could be like the poisonous air. The poisonous air or like smoke from the volcanoes could block the sunlight and it could create colder weather on the earth.
According to the text. Good job. Okay, does anyone have anything that they would, I know I saw a few notice some information that helped explain how they could be helpful. Okay, Sophia?
I would like to support what Joe said and Lismore because the air can let the crops die and people can't grow crops or pick them out because the crops are going to be dead.
Okay, I agree. I want one more that shows how they are harmful. Can anybody share one more way? I saw a few of you notice it. Vinny?
It could also be harmful and destructive because every time like a volcano erupts, it has a chance of triggering earthquakes and some
Tsunamis. Okay, yes, somebody else shared that. Okay, I'm gonna have Sophia share one of the things that she noticed, and I'm not sure anyone else did, but there is one more way they could be helpful. What did you say about the minerals? Okay.
I know. They also bring minerals from deep inside the earth to the surface.
Okay, so they also burn minerals from deep inside the earth and bring them to the surface. Very good job. Okay, boys and girls, great job on your discussion on that. If you'll give yourselves, let's do a firecracker cheer. Ready? 1, 2, 3. Ooh, good job. Okay, so in order to help you better understand how, again, some of the ways we've just discussed how magma can turn into lava and also how volcanoes can be both helpful and harmful, we are going to experiment with, we're going to witness this firsthand with a model of a volcano. So you will find some supplies on your desk. You are going to work with a partner. Boys and girls, if you'll come over here for a fishbowl explanation. We just always record what they see and what they observe, and then think about it after they're done. Okay, so you're going to be filling this out as we go along. in order to activate your volcano, you are going to make sure that you have all of your supplies. This right here is the baking soda. You'll fill the volcano with baking soda, and then you will slowly pour the red vinegar. Okay, slowly. And then you will record what you observe. Okay? Any questions?
No.
Yes.
How big is the explosion?
You'll see. You'll get to know. Any other questions, TJ?
Will it come out slow or fast? Or?
That's a very good question. So you are going to observe that. As you're working through this, you'll observe that. Okay? We know that sometimes we read that sometimes volcanoes erupt slowly and sometimes they're violent and explode rather suddenly. So you will have to see what yours does. Okay? Liana? Boys?
They erupt because of the pressure that builds inside every year, and then once year comes up, it starts erupting.
I love that you have so much background knowledge on this, and that's perfect. So that is likely what happens, but we're going to witness it here. We're going to simulate it and witness what usually happens with a volcano.
How about you do the
Okay?
red stuff and I do the white?
So if you'll go back to your desks, make some observations before you start. Okay, work with your partner to discuss what you predict will happen once you combine the baking soda and the vinegar. What do you think? Okay, I like that Eliana and Audie are talking about it first. Okay, go ahead and make your...
A little bit, and then I come out.
Okay.
When I pour this in and then when you pour this, I don't know when you pour this slowly, it'll just like burst.
What do you...
In my opinion, I think the volcano will erupt.
Okay. What might that look like? What are you going to see with your eyes?
Red.
Oh, I know. You're right. You didn't. I'm sorry.
And it's gonna come out, I think.
Okay, I'm going to give you about another minute to finish writing in your predictions. Okay, magma and lava are? Good job, boys and girls. If you will, you have permission to go ahead and conduct your experiment, but I want you to pay close attention to what you notice. Okay, you will be making some observations, some documentation as to what you actually see happen. So remember, start with the powder, and then you pour in the liquid slowly. Do it slowly, boys and girls.
Looks like big red. Big. Look.
It's like green.
Wow! Mine went all the way to the... Mine went out.
Yes, it does.
My prediction's right.
It looks like bigger.
Okay, boys and girls, talk to your learning partner about what you noticed. What did you notice? Okay. And then you'll write this down on your recording sheet. Yes, definitely. You confirmed your prediction.
All the bubbles came out on the side.
The vinegar, it like erupted and it started pouring out.
Pouring down the side. Okay. So as you look at what you're observing, I want you to think about how new land is created from magma. Okay, look at the way the volcano originally started. When it poured out, look at where the magma is settling and how that would create new land. You see how that would make more land and make the volcano expand.
Miss, it's cooling and it's like
So all the red would eventually cool and starting to get rock solid, and that would be new land, okay? Exactly, that's exactly what happens.
Probably like how it evaporated.
Some of it will evaporate, but a lot of it will form new land. Okay, so your last geologists, ready? Ready to rock. Okay, boys and girls, I want you to pay close attention to the very last part of your documentation. Step 3 says, explain how this relates to what we learned about how volcanoes form. So make sure that you explain how this is similar to a real life volcano. Okay, you can talk to your neighbor about that if you need some clarification.
Is it like how it's cooling down on the inside?
So this helps you better imagine how this works.
Mrs. That's
Okay, I'm going to give you about 5 minutes. Actually, I think...